So it's visible, am I right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Just is it visible?
Yes, sir.
Sir.
Yes, sir.
No, but my headphone is not working. Just let me log out once and then come back and join. Just a minute. Continue these things. My voice is clear.
Yes, sir.
Yes, sir.
Sir.
Fine. So let us do its the new chapter that is called testing and debugging. So far we have seen the different phases of that what is called software engineering. So now let us see almost the last part of the development phase. Okay, uh, there are two phases are there majorly. That testing is the last phase of the development phase. Okay? And then the overall software engineering phase contains another phase that is called another part that is called maintenance. But from the development phase point of view,
Sir,
testing, yeah,
sir,
and
your screen is not visible.
is it like that for all everyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Am I audible?
Yes, sir.
Yes, sir.
Sir.
Phone is not working. I don't know. Is it visible now?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So now we are in the last phase of the development phase, the last part of the development phase that is called testing, and then the testing and debugging. Okay. Now, what we're going to learn different types of testing. Okay, the black box testing, white box testing, debugging, unit testing, integration testing, system testings. So that everything we're going to learn uh, during this lecture. Now, what is basically the test? Okay, what how do we test a program? So whenever we write a program, whenever we write, I mean, every time, whenever you write a C program or whatever program, we normally test that program. Am I right? What is the purpose of the testing? The purpose of the testing is to check whether my program is behaving as per our expectation or not. Okay, so you are trying to find out the primary number, the prime number checking. So now you give some input and you know actually the output. So you first intentionally you select a kind of a prime number, and then you expect that your program should say that it's a prime number, and if you're sending a non-prime number, you expect that the output should be non-prime it will the print. No, it's not a prime number. So what we do, we just take some as example values, sample values, and we know the expected output of that. What should be the correct output, and then if it uh, behave, if my system or if my program behave as per my expectation, then we'll say my program some way is correct, not fully correct, but some way it's correct. Okay, some way is correct. And normally, what happens most of the time, in a hurry, the programmers what they do, they basically put some sample values, so select so in some logic of some way or some random values they select it, and then they put it, and if you get some correct result, you feel that your program is absolutely correct. But testing is not that so important. Sorry, that's so easy, because there may be so many cases you may miss out, which you need to test it with some values, so that you can say finally if my program is fully correct. Okay, just mere passing some of the tests doesn't mean that there is no error in your program. Okay, and in a software company, what happened actually, the tester having a separate team. Okay, normally those who are developers, okay, those who are developers, other than unit testing, we have already studied unit testing. Those who are developers, they normally don't assign, the company never assign a task of testing to the team. Okay, instead they are going to be completely independent team will be there, who will going to test the software or software modules. There is a reason why there is a separate team, because as a programmer, okay, as a programmer, you never want to see that your program is failing. Okay, that's a kind of a phobia, always it's there in the mind of a coder. Okay, they don't want to see that their code is failing. Okay, that's why whenever they do a testing, they normally do it very careful way. Okay, so that I mean, they never try to destroy their own creativity or in own effort. Okay, as a result, there may be high chance that error may remain undetected. But if it is done by some independent team, okay, who are not at all related to the coding, then their task is just to make the software fail. That is, their task is very negative. The task has been given to that team, that you some way you show, I mean, destroy that software. That is your Your job is not to safeguard the software. Your job is to some way break that software, find out the loopholes in that particular software. That is the target of the testing team. So in that way, if it pass through very rigid, what is called testing phase, then there is a chance that the error may be detected during testing itself. Even then, there are situations where there are some errors which may be remain undetected during even the testing phase also. Okay. And what normally happens then, after that, once the software has been delivered to the customer, and customer will start using that thing, and during the use of that software by the customer itself, it may leads to various kinds of error. And then the development team will going to fix those error while in use of that software. So that means this error corrections, debugging, updations of the software, so it's basically a continuous process. And what that phase is now, what we called it as a maintenance phase. Okay, so after delivery, whatever the task will going to have come, so that is called uh, your maintenance task. Maintenance task. So maintenance is normally goes till the end of that software. Okay, life of that software. Okay, so it's a most longest phase of software engineering process. So anyway, so basically testing is a program is just to give some values, and then with an expected output, and then try to check whether it's behaving as per the expectation or not. So system testing, you have to give a whole system. You have to consider the whole software as a system. You have to run that thing in kind in a some hardware platform and all. You have to run that system as a whole, as a package, and then you have to give some input, and then you have to check the given output. Okay, and in that case, in case of that overall system testing, mm, it will going to check the expected output based on the SRS document. So it must comply with the SRS document. Whether the whatever it has been specified in the SRS document, whether it's performing exactly like the required, activity required, I mean, or expected output or not, as mentioned in the SRS document. So that is what we called it as a system testing. One is program testing, another is called system testing. Program testing is very small. Program testing is very small. What you already did it during your C program course or C++ or any other programming language. You are writing small programs, and then you are basically try to correct those programs that are running those things like unit testing, and be giving some input, and you are waiting for the expected output, and accordingly check. But system testing means the input will be as per the SRS document, and output also should be as per the SRS document. If it is giving, it's fine. If not, then there is some error in the overall software. So now, if during this program testing, if your program does not behave as per the expectation, okay, because you know these things, you have to find out that in which condition this actually failed, okay, and then say you are giving a number which is not a prime number, but it's showing prime number. So naturally, you have to note down. When I have given a particular value, say 5, it should show that it's a prime number, but it's showing now non-prime number. So you have to know, write down that this is the example. Then you have to go to the code and you have to fix that problem. What we call it as a debugging. Okay, and then you have to correct that problem. Okay, so debugging and correcting the problem that wherever that particular error happens in a program. Okay, now there are various terms which are there: errors, faults, failures. You know these things. Basically, every day, now and then, on the regular life also, we have come across these terms called error, faults, or failures. Okay, so what is those things? Let us see. Mm, Basically, when there is a kind of an error happens because of which only something fails. Okay, it may be software or it may be something else. Okay, so if in our life, if you say I'm really a failure, okay, it means some error happens. Okay, some kind of error happens from my side, because of which it leads to certain level of failure. Okay, so even in the software also, or any day-to-day life also. So if there is any failure occurs, it means there is some bugs or defects or error is already existing, because of which it's failing. Okay, so that's why error actually indicates sorry, failure indicates the presence of error. Okay, or sometimes we call the failure is a manifestation of an error. That means failure indicates there is some error in the system. Okay, but always there, I mean, it just because of some small error, it doesn't mean that always that it leads to certain kind of failure. So that means until unless your error is not recoverable some way, or difficult to detect or debug, or it leads to the whole collapse down of the system, such kind of small errors cannot say it leads to certain level of failure. Okay? So fault is basically what we call more technically, that it's basically fault is what? It's basically a incorrect state. Okay, if, during program executions, if it goes to some incorrect state, then it is basically called program, what is called fault in the program. Say you are dividing or you are mishandling your what is called I mean pointers and all. So due to maybe due to some variable names, variables, values that you are sending. Say you are sending x by y. Okay, so x by y. So if it is going everything fine, okay, if it's running everything fine, but because of some input for the y, there is a chance that there will be a division by zero case will going to appear. Am I right? X by y. So till there is no value user is giving for y as zero, there is no issue. But when someone gives the value of y as zero, then it will going to be a great fall. Okay, so that means some way your program should uh, keep checkpoint of that such that y should never be zero. Okay, then otherwise it will going to be a big mistake. You know that something divided by zero cannot be handled by a computer. Okay, any value divided by zero cannot be handled. So it may start behaving unexpectedly, or possibly the user may not able to detect this thing. So if you can handle it at the prior stage, like while giving the value of y, you should give a check, or before executing x by y, if you can put a check if y is greater than y greater than zero, then only you will execute x by y. Then there is no issue. But sometimes due to um, um, planning, lack of planning, or proper understanding of the code or its logic. If you go on doing these things, hopefully you will ended up in such kind of faulty situations. Okay, so the fault also may not lead to certain kind of failure. Okay, the fall of or the fault also in the software can also not lead to certain level of failure of the system. Okay, now how to do these things. Okay, how to do these things. Basically, to test a software, you need to design some sample examples or septum values. Okay, for testing. Okay, that and it maybe it's not, maybe say for a prime number, you may take two three numbers. Okay, you will select two three numbers to check whether your program is correct running or not. You should not do in only with one value, right? Say you are testing with five, and in some way it's giving it's a prime number. So you should not feel always satisfied. Am I right? See, always you have to take some more numbers. Say a non-prime number also you have to take. Am I right? So you when you will give it, so I mean, it it will going to give you non-prime. Okay, so but if you test it with prime, say just five, and you say yes, and it's showing five, it's a prime number. It doesn't mean your program is correct. Why? Because it by mistake it who knows, until unless you test it, that for any value it is giving it's a prime number. So until unless you test it with a non-prime number, you cannot say that your program is correct. Okay, so that means you need to select a set of values, okay, through which you can do a test, and that set of values are normally called test case, or sorry, test suite. Okay, first is test case, what are the values, and then the collection of those values are normally called test suite. Okay, the test suite. So the test case is basically a more formal way, if you can write it like that. Then it basically triplet values I, S, and O. Okay, what is I? I is basically the data to be input to the system. Okay, that value that you're going to give it. Then S is basically the state of the system. That means in what state that system right now is. Okay, and O is basically the expected output. Say for the prime number, you are taking some test cases for I is 5, 9, 4, 6, 3. Okay, so and the state is just to the state of the system is just a prime number checking. In fact, in this case, there is no state. Okay, so so in that case, what will happen? That you know that whatever value I have mentioned, what is the expected output? Say 5, the corresponding output is prime. say 7, the corresponding output is prime. Say 4, the corresponding output is prime, a non-prime. Then 3, so it is a non-prime. So you know what is the input and what is its corresponding output. So this set is you normally call it as a test case. Okay. So, so let us assume some to understand better the system. Sorry, the state of the system. Say you are executing certain, I mean, what is called, say a text editor we have. Okay, a text editor we have. So text editor have different state. It's maybe in opening state. It may be a closing state. It may be a editing state. So many states which are your particular system will go be. And now for every state you can think of, say for editing state, these are the input and these should be the output. And what is the expected output? Now you have to check it with all, and then you have to check it whether it's giving the expected output now. If it is giving, it's fine. If not, then there may be some error which is there. So that statement for a big system, currently which mode it is actually running, that is basically called the state of the system. And there are a few more terms, that is called verification and validation. Okay? These are very important terms, that is called verification and validation. What is verification? Okay, so verifications are basically just to see whether the output of one phase of the development in terms of software engineering conforms to its previous phase. Means uh, whatever output is given by a design phase, okay, it's a design phase, whether it is conforms, okay, or agreeing with the SRS document or not. Say similarly, in case of coding, okay, in case of coding, you are verifying, what is verifying, that what is the output it is giving, whether it is as per the expected, as per the design or not. Okay, say whatever the performance is or whatever the outcome of the particular phase, that is coding, whether it's as per the design phase or not. So that means just the previous phase, if it is conforming or not. Okay, so that means the verification is basically a phase by phase process. Okay, it's not going to be something very big. Small phase you are completing, and then you are checking whether the it's satisfying the requirement from the past or few previous development phase or not. So that is called verification. And what is validation? Validation means the whole system, the system as a whole. Okay. Now, as I have mentioned, that system testing, you can say the validation means the system testing. What is that? It's basically checking the whole system. Okay. And then given some input, and it matching with the SS document whether that system is performing as per the expectation or not. Okay, as per the some specifications mentioned in the SRS document. So it must conform or conforms the whatever it's the input output should be written in the SRS document. So that means verification is the small phase by phase checking, and validation is basically the as a whole, the whole system checking from there. So verification is basically just to contain the error. Okay, that means if you check every after putting placing every phase, or sorry, every step of your software development, if you just go on checking every time with the matching with the previous state, then possibly you can contain or get hold of the error, which but because of some error it may propagate. Okay, say some error is there in design. Okay, and during coding, if you cannot detect that thing, so detect that thing, that error and all, possibly that error will going to propagate to the next phase, that is in the testing phase or in the maintenance phase. So that is most dangerous. Okay, so our target is just to check every phase and try to stop any error to be propagated to the next phase. Okay, so I mean that is why in every phase we will do a kind of a verification such that any kind of error uh, can be get hold of that, stopped or contained. Okay, contained within that particular phase, as that it should not propagate further. Okay, whereas the aim of the validation is just to check whether my overall system is error free or not. Okay, overall system, it's nothing to do with the phase by phase, it's with the whole system together. So verification is important from to uh, get hold of any further error propagation, and validation means the overall system checking. So verification in other way, it says that whether we are going in the right path or not, whether we are doing the right thing or not. Okay, and validation at the end will say whether we have done something right or not. Okay, try to understand the two differences. So one is whether you are doing every phase and checking. So you are just looking back and see, are you in the right path? Okay, whether you have come in the right path, whether you have done something right, that is called verification. And what is validations? Once everything is done, then as a whole you're going to see whether whatever you have done, is it the right thing that you have done? Is it the thing that actually you are looking for? Is it the software that actually the customer is looking for? So these things is basically called the validation. Okay. So that validation is a very term in not only in software but any other computational parts also, computational activities also in computer science. So validation is very important. Even in mathematics also, validation is also an important activity. Now let's come more formal way what is called the testing. The aim of the testing is to identify the defects in a software product. So you know now what all the terms. Okay? So just the testing, the role of the testing is to just detect. Okay, is there any defects in the software product? Okay, but as I mentioned, even after if you say that your testing is fine, there is no defects you have encountered, even then you cannot say or you can give a guarantee that your software is completely error free. That's why this process of testing and debugging, okay, basically the debugging will going to continue till the end of the life of the software. Okay, because the, I mean, you cannot say when the error will going to generate, okay, during the use of the software. So that means if during testing, if you do not, if you have corrected many errors or if you have not find any error, it doesn't mean that your software is error. Error can come at any it can be detected at any moment of time. So the input data domain of the software product is very large. Okay, because you don't know, see, anything can happen from there. Okay, so basically it is not very practical to test with everything. You cannot say for a prime number. Okay, you cannot test with all the numbers which are there in the earth. You cannot. Is it possible? Never possible to check whether my prime number checking program is correctly doing or not. What you are doing, basically you are selecting some sample inputs. Am I right? Selecting also sample input, what we call it as a test case. Okay, so practically it is never possible to check with your program with all the numbers. That is the reason why there is a chance of failure. Okay, chance of failure. So the but you cannot do anything because even after testing also there may be some error may occur. So that is the thing, that testing does not, however, expose many errors. Okay, just you have to be very specific in that case. Okay, so testing basically provides a way to reducing that effect of error. Okay, and some way, I mean, until unless your up to certain level, if your system is not performing error free, so in that case you can sell or deliver that thing. Say for a flight reservation system, okay, or say for a railway reservation system. Can you imagine the how complex that system is? Now there, because of some reason, because of some say network error, because of some database error, because of some other faulty programs, there may be there may be chance that that the same ticket for the same seat for the same train, okay, for the same journey date, may be allocated to two different persons. Can you imagine what will going to be the consequences that happen? That same seat will be allocated to say two different person. So think about it, that how critical this is. So testing some way ensures with all such situations that it will never going to happen. And so far I never heard such situations that happen, that same seat allocated to two different person at the same time. Okay, so that testing basically ensures. So if it passes, then you can say okay, fine, some way my software is very confident and are some way error free. Even then the error chances of different errors may occur. Okay, and that's why still whatever softwares are available, weak softwares are still they are in correction mode, or maintenance modes are always there on. So as I mentioned, this is basically the last phase of development, the part of development phase, and most important. Okay, and it is the maximum effort that is required for in terms of development phase. Okay, this is the most one time taking. So in any software development company, most of the people are recruited for testing, for the member of the testing team. So sometimes what happened, even as a programmer also, I have seen that you give normally very less importance in the testing, because you have a tendency, um, I mean, that you don't want to see your program failing or unable to perform. So if some way you have completed your programming, if some way you are getting a compilation error free message, then you try to test it with one or two values some way, and try to say that my program is okay. So try to want to in hurry you are be submitting that program. So that is the thing that it is happening even development engineers. They normally having this tendency, okay, and they normally give very less importance to the testing and all. That is why there is a separate team. Okay, uh, so testing is like the other part of the software. It's very crucial and important phase. Okay, yeah, challenging also. Okay, like the other phases of the one. In fact, I must say that testing is even some more important than some of the other phases also, um, because I mean, if you unable to detect that error, it will going to be propagated and reach to the customer with that error. But with previous phases, if you do a kind of a verifications in every phase, chances are very likely that you may detect those error in early stage. I mean, for say, let us assume for specification phase error or design error or coding error, that can be detected. But if the testing you skip it some error, then it will directly go to the customer, and which is it's very dangerous somewhere. And testing also, it's not a routine task. You need certain level of creativity just to say in different angle, like what is the possibility of error that may be there in my program. Okay, so say you may check it with minus one, my negative number for prime number. I'm talking about the prime number checking program. You may test it with negative number. You may test it with very high large number. You may test it with zero. Okay, you may test it with prime number. You may test it with non-prime number. So, or you may test it with float number. So, in all the things you have to think it at the early stage, that what will going to be the values which I am going to test my program. So software products are basically tested in three levels. One is unit testing. We have already discussed this unit testing, but again I'll discuss integration testing and system testing. Okay. So what is that unit testing is? Unit testing means that will be going to be taken care by the developer. As and when they are developed, you are writing a program, you are very minor way you are basically testing your own module. Okay, testing your own module. Okay, and then and that relatively easy because you are actually dealing with a small part instead of dealing with a large part. Dealing or testing a small part is quite easier. Okay, to check whether there is an error or not. Okay, so these modules are basically you are testing together. So if you combine all the modules together and then test it together, it's very unlikely that you may able to detect or fix the exact reason of some certain level of failure. Okay? So that's why unit testing means small modules you are developing and then you are testing. That is called unit testing. So if you can able to detect at the very early stage in the module level, and if you can debug it, then what will happen? It will basically reduce the chance of error when you integrate all the modules together. So what programmers do? They carry out unit testing. Okay, immediately after they complete the coding of the particular module, the way that you are doing whatever programs you are writing in C, C++, or any other program language nowadays, now during your MCA course, these are nothing but you are doing. You have done some unit testing on it. Okay, you are writing a code and you are just checking whether it's working or not. Now, how to design the test cases. Okay, we have talked about test cases. How to design the test cases. So, test case design is not something arbitrary. Okay, and also you cannot test if you can able to test with any number, say the prime number. If you can able to test with any number in the world, then there is zero chance of any error that may happen. Okay, but since it is not somewhere possible, okay, exhaustive testing. So um, that's why we have to be very careful in selecting those sample test values. Okay, what we call test cases. Okay, or that actually forms multiple test values. They normally actually form the test suite. Okay, and that test suite also should be a bit reasonable size. Okay, so that it can able to detect the errors as far as possible. So if the test cases are selected randomly, so you may take some random number and do that thing. It's not a very good idea. Okay, if you select very numbers randomly, okay, I'll check my prime number program with any random number. Okay, that then sometimes you may end up with failure in not failure, end up with I mean something that there is no error. Actually, in true sense, you could not able to detect that error in that thing. So. So that we're going to see with some example, what are the scenarios where if you select some number not carefully, then the error remain undetected at that place. So if you are taking randomly any number and if your test case is very large, okay, then also it's not a good area because you have randomly means there is no control of that. It may be any arbitrary number. Possibly in the error case, you may miss that in your test case that number is not present, which may able to detect any error in your code. Say for example, there is a program that we have already written to write a program that finding the maximum of number out of two numbers. So it's a very simple program, right? It's a simple program. Okay. Say if x is greater than y, max will be this, else max will be this. Now where is the error? Error is in both the cases you have mentioned x. So the else part should have y. So by mistake, by programming mistake, you can say you have written. So uh, what is called logically or syntactically it's absolutely perfect. There is no error. Okay, there is no error. So now, I mean, logical error also it's very difficult to detect over there. So now say let us assume we have taken some values where always the value of x is greater. Say the second case, x3 y2, x4 y3, x5 y1, the last one. I'm talking about this last part. Okay, I'm talking about the example, last example, this example. Okay, so if you consider these things, if you take these things, you never able to detect whether there is an error happening or not. Okay, but you have taken so many. You see, there are three test cases you have taken. You can go on taking more, where uh, where x value is always greater than y. So until unless you are taking a test case where y value is greater than x, in that case it will never going to be able to, you are able to detect that there is some error is present in that particular code. Okay, so that's why careful selection of the test case and making the test suite is very important. It's if you take randomly any set of values, okay, it doesn't ensure that there is no error maybe over there. So you have to be very careful into selecting that. Now how to select? Okay, how to select? So there are two different approach. This is also testing also there. So one is called white box testing or glass box testing, and another is called black box testing. Okay, black box testing, and accordingly you have to design the different test cases for white box testing as well as black box testing. Okay? So this is also design test case design process. At the same time, they are also called the testing, black box testing and white box testing. Now let us see first the white box testing. What is white box testing and what is black box testing? Let me tell you first the black box testing. What is black box testing? A module you're going to take it or a program you're going to take it, you don't know the inner details of the program. It's somewhat like a dark box, black box. From outside you cannot see the what is there inside that box. You know that I'm going to pass a input and I can expect a particular output. If it is giving, fine, no issue. So that is the black box. It's very simple. You're taking a function called prime number. Okay, is prime check. So you'll give a prime number and you will expect that it should say prime number. And then you are giving non-prime number, you are expecting a non-prime output. So if it is giving, that is done, black box. But what is the other one is the white box is you have to check the program. Okay, program line by line, the syntax of the program or logic of the program line by line. Say. Okay, different part of that program. Black box, no checking of the program. You take the whole module, test it with some inputs, and see the whether it's giving output or not, expected output. But in case of white box testing, you are looking into the structural structure of that program, line by line testing of that program. That is called white box. That means that box, what the inner details or what the content of the box. If I consider module as a box or the software as a box, you can now see from the outside what is there inside. That's why it is called white box. Okay, that's why it is called white box. That means you are basically you can able to see or testing each and every line of the module or the program. Now, how to do the white box testing? There are different types of testings which are there. Okay, statement coverage, branch coverage, path coverage, condition coverage, mutual test coverage, testing coverage, data flow based testing. Okay, so let's see the different types of white box testing. What is statement coverage? In case of testing cover statement coverage, I'll going to create or design test cases in such a way such that every statement of that particular code or program will going to be executed at least once. Okay, that means statement every line should be executed once. Okay, so I have to create test cases in such a way so that every line should execute. Until and unless every why we are going to do statement coverage, because until and unless you can able to execute each and every line of that code somewhere, okay, then it's very difficult to say where is the error exists in the statement. Say in the previous program of maximum, if you are not taking any value which where y value in this example, in this case, until unless you are taking some value which are where y value is greater than x value, you are not able to execute all the line. In this case, you see here, in this particular case, it will not going to execute all statement. It only execute this statement only. Okay, it never execute this particular statement. So that's why until unless we do a statement coverage, then we select the test cases in such a way that every statement will going to be executed. Okay, so if we don't do that thing, the what is called error will remain undetected in that case. For example, say there is a function. Okay, do you know what function it is? The program it is. This is a program for finding the GCD. Okay, GCD algorithm, greatest common divisor. Okay, that this is the it's called Euclid's algorithm for calculating the GCD. Okay, so say this is an example. The program is there. Now you are selecting some test cases like x3, y3, x4, y3, okay, x3, y4, x3, y4. Okay, sorry, x4, y3, x3, y4. So if you run it, you'll observe that it will going to execute all the lines. It will going to execute all the lines. That means your selection of test cases should be very very creative and very very clever, so that it's not random. Am I right? You are not taking any arbitrary values for the test cases. It's a well planned values that you are taking, such that all the statement of the program should execute once. Okay. Now, what is branch coverage? Here, it's not emphasis is not giving in on statement, every statement executions. What it says that it should execute every branch. Branch means if then else. Okay, if then else, true false. So that is called branching. You know, if then else is basically branching. So it should once it should execute with the true value. That is in case of max values, that x greater than y is true, that condition, and x greater than y false condition. Okay, that means y some in one place is greater than x, and one place x is greater than y. So both the conditions, true and false conditions, to be executed once. So you have to select the test cases in such a way such that both true or false of a branching should occur. So what it says that branch coverage is much more stronger. Okay, much more stronger than what is called statement execution, because sometimes statement executions it's not a deep. Basically why it says that the chances of error normally happens in those conditions, in those branching statements or looping statements. Okay, so that's why if you do it, it's fine because it's a superset. Statement coverage is basically superset, that where you are covering all type of testing, branching, looping, everything, all type of coverage you will going to do that thing. But sometimes it's very difficult to, for a big program, it may be difficult to plan for a very good test thing. But what it says that if you at least able to test the branching coverage, test case do the branching coverage, then itself is it's very strong. Okay? For this example, the coverage, what will happen? There is if then else. So in one case, if x is greater than y, so you see here what are the conditions that it has taken. Uh, First one is x and y is equal. Second one is x is greater than y. Third one is again x is greater than y. So somewhere these are redundant. Okay, the greater than y. And the fourth one is x is less than y. Okay, so at least these three, x3, y3, that is same equality condition, greater than first component x is greater than y, second is y is greater than x. So I mean everything you can you put it in the test case. So another thing is that condition coverage. Okay, branching coverage we have seen, the condition coverage. Okay. So conditions, the composite conditions, okay, that you are joining and or something like that. If you are doing these things, that also you have to check it whether it's true or false or not. Okay. Say consider a conditional expressions. What is that? C1 and C2. There are three variables: C1, C2, and C3. Okay, so C1 and C2 or C3. Now, what will happen? Uh, First, C1 and C2, you have to take a value such that C1 and C2 conditions should be true. Okay, and one case C1 C2 should be false. Okay, and C1 and then the overall, or C1 and C2 should be false or C3. So in case C3 also sometimes true, C3 is sometimes also false, that should be there. So let me explain it more better way. So what are those values? So in this case, C1, C2, C3. It's somewhat like your digital logic, whatever you have done. What will happen in that case? First case, both are true. Whatever be the value of C3, you know what is the expected output. Okay, so this should be 1. You know this is going to be true. 1 is 0. 1 is 0. You are taking whatever be the condition. So you can say it's a don't care condition. You can say. So whatever be the condition, okay. So in that case, what will happen? Um, in this case, if it is one, only one is one, then the whole output will going to be one. In this case, 1 0. But now it depends on C3. So if C3 is one, then only it is going to be one. If in this case, if it is 0, then it is going to be 0. So then you can think of all combinations. C1 like 0, then C2 is 1, then accordingly C3. So all conditions you have to make a test case suit in such a way such that this condition you can check it over there. So that is what we call it as a condition coverage. Hopefully you have understood. If you do not understood these things, just let me know. Now path coverage. Okay. So uh, something that we have talked in the last presentation, last class, that is called during scheduling. That's some critical path type of thing. Same, relatively almost similar kind of concepts are there also. That is path. So that means every program having some path. Okay, every program having some path, and then you have to ensure that what is called that line should be executed, that path should be executed. Okay, a path should be executed, every path. So now how to do these things, how to calculate that path, how many such test cases need to be done, let us see these things. Okay, so this path is nothing but a graph we have seen in the last class also, like the different activities and the dependency among the activities that forms basically a path. Okay, so nodes and edges, so we called it as a control flow graph. Okay, this is what we called it as a control flow graph. So that graph or path, it's very important for that particular type of path coverage. So it's basically a collection of, so nodes are nothing but here a particular statement, and any dependent statement which is there from one statement to the other statement. Okay, that we called it as we can form a graph. I'll come into some example. Okay. Now, how to draw that control flow graph? So we basically number every statement, and the dependency among those statements are drawn through arrow. Okay. So let's go with some examples. See the same what is called GCD program. Okay. Now what we will do? We'll going to number every statement. The first line, second line, third line, fourth line, fifth line, sixth line. Okay. Now you see here what is the dependency. So every program must start with this while. Okay, this while statement. Let's say we one. Now after that, it will go to this condition. So condition means branching. Sorry, branching. So branching, what is that branching? That either x is greater than y or x is less than y. So there are two things. If it is x is greater than y, it will go towards 3. If it is less than x is less than y, then it will go to 4. So that branching, that's why it's called branching, that it will take a shape of branch. Okay. Now, if whether 3 or 4, it will end up to the line called fifth line. Okay. Now, since it's a loop, if the loop is not ended up, then what will happen? From 5 it will again go back to 1. So it will continue. It's a loop. It continues. Now once the loop is false, it will come back to the end, that is return x. Now statement return x. So now you can see we are actually forming a kind of graph, what we called it as control flow graph. Okay, so every statement will going to be numbered. Okay, and we'll make it as a node, and the dependency among the lines will going to be made, described or denoted as a arrow. So you see here, the 2, the line number 2 is dependent on line number 1. Until and unless line number 1 or statement number 1 is executed, you cannot execute line number 2. So that means 2, the statement number 2 is dependent on statement number 1. Similarly, statement number 4 is dependent on statement number 2. Statement number 3 also dependent on statement number 4. And that 5, that is end of that loop. End of that loop is dependent on the execution of statement number 3 and statement number 4. That's why both are basically merged or ended up to 5. Now from 5 it will go back again to the 1. So in that way you can basically create a control flow graph. Now this is graph that we have seen. So you can see from the diagram that say for a sequential statement. Okay, condition and branching we have seen. Sequential statement means one after another. In that case, simply see in this particular example, in this particular example, the statement 2, the statement 2, the statement 2 is basically dependent on statement 1. Why? Because to calculate the value of b, you need the value of a. Okay, you need the value of a. So that means the value of a is needed. So that means first assignment of a equals assignment, that is a equals to a assigned 5 is assigned to a, or a equals to 5. You cannot execute b with the statement 2, that is b equals to a into b minus 1. So that means that's why you are showing the dependency like from a to 1 to 2. The second statement cannot be executed without before executing statement 1. So that dependency you can show it using a arrow from 1 to 2. Similarly, the branching or selections, you can say it's also called selection. That the statement 1 will going to be executed first, that is the if condition. Then it may go to true or false statement. Both can possibility happen. That's why there is a bifurcation in the diagram. And then it's ended up to statement number 4. That means once, whether it's a true or false, once it's executed, then only you can execute statement number 4. Because you cannot execute this c equals to c into c, this line, until unless you get the value of c either 3 or either 5, and that 3 or 5 depends on what is the value of a that you are assigning. Okay, so that way you can draw the such branching statement. Iterations, we have already discussed that every statement like statement number 2, it will start from the first while. Okay, and then it will come to statement b, and from b you are calculating the next one. Okay, and then from there you are basically going back again to while loop. Okay, while loop, and it will continue until unless that condition is false. Okay, and then once it is false, it will come back and execute the last line, that is fourth line, c equals to b plus d. Okay, that until unless it is executed. So that is the thing, that node and edges that we have drawn like a graph. These are normally called the control flow graph, and there may be several such ending nodes which may be there. It's not necessary that it may end up in one place. A program may end up in multiple places. No single ending point may be there for any some of the programs. Now, what is important, once we have a control flow graph, then we have to find out how many such paths are, we have to check it. Okay, how many such paths we have to check. So how to calculate? There is a called MACAP's cyclomatic matrix formula is there. What is that? That E minus n plus 2. E minus n plus 2, where n is the number of nodes in the graph and e is the number of edges in the graph. So that will going to be called the cyclomatic complexity. Okay, so that is a measure. I'll come into that. That is a measure, that cyclomatic complexity you have to calculate to show that how many such paths you need to cover. Okay, or how many such test case you have to create for those paths. Say for this example, what is the cyclomatic complexity? You see here that how many edges are there. Okay, how many edges are there? E is the edge, and how many nodes are there? Okay, uh, plus 2. So what is that? How many nodes are there? There are 7 nodes. You see, sorry, edges are there. One, 2, 3, 4, 5, 6, 7. Okay, what is that? You see here how many edges are there? One, 2, 3, 4, 5, 6, 7. There are 7 nodes. Okay, and there are 6 nodes. Sorry, 5 edges. Sorry, 7 edges and 6 nodes. Okay, and then e, that is e minus n. No, e minus n. This is e edges. N is the node and plus 2, so it will come out to be cyclomatic complexity is going to be 3. Okay, so these 3, that means you will going to have 3 different paths. Okay, 3 different paths. What is that 3 different paths that you have to test it? One path is this, one path is this, one one path is this, 2, and another path is from here to here. So that's why you have 1, 2, 3. So this is such a nice simple equation, but it can able to tell you how many paths are actually basically you need to test it. So first path, you have to create a test case. You have to create a test case that will pass through this. It can avoid this path. Another one can go by this path, and then you can avoid this path. And another one is directly from while loop to the end. That means you will have to give some conditions, false condition in the while loop in that GCD program, so that it can come to end. So all the conditions you have to check it. So if you do not understand, just let me know. Okay, if you do not understand the cyclomatic complexity, just let me know. I'll explain again. You may interrupt me. So another way, what it says that to calculate the cyclomatic complexity is the number of bounded areas plus 1. Okay, number of bounded areas plus 1. Earlier we have seen E minus N plus 2, and another equation says that number of bounded areas plus 1. Now what is the bounded area? Okay, so any region enclosed by a nodes and edge sequence are basically called bounded area. See in this case, okay, how many bounded areas are there? Okay, uh, um, so basically the what is that? The region enclosed by a nodes and edge sequence. So this is one bounded area. Okay, this is one bounded area, and this is one bounded area. So I mean, what it says, this is one bounded area sequence of this one path. This is another bounded area. So there are two bounded area, and what it says, the bounded area plus 1. This is it will going to be 3. So the psychometric complexity will going to be 3. So that means same values are remain same, whether you are using E minus N plus 2 or bounded area plus 1. In both cases you are getting three test suites that you have to create for all the 3 different paths that you have to do the path coverage. Is there any query up to that?
No, sir.
Okay. Uh,
Sir,
Now, black box testing. What is I have mentioned already? What is that black box testing? Test cases are designed just to check whether my module or function is performed as per expectation or not. That's the thing. This is also sometimes called the functional testing. That means you are just checking the function, whether it's functioning properly or not. That particular program, say is prime, whether is prime is functioning or not. We're not going to checking the line every line by line testing. We're going to check as a whole the function is prime is correctly working or not. That's what is called functional testing. So how to do that black box testing? There are two different approaches. One is called equivalence class partitioning, another is called boundary value analysis. So what is called equivalence class? Uh, if your test cases of similar nature, okay, similar behavior, if they do the similar behavior, then we call it as a equivalence class. That means say for example x greater than y, okay, x greater than y. So for the condition if x is greater than y, so if you take value x5 y2 x7 y9 x7 y1 or x10 y3, all are of same class. Why? Because in three cases x is always greater than y, so then that means their behavior is going to remain exactly same for all the such test cases. So that's why it is called basically called the equivalence class. Okay. So then what will happen? The input values you have to first partition is done. Okay, because you know that they will going to behave similar way. If you take for a if greater than x greater than y, in case if you are always taking x greater than y values, any value you take of that combination, it will going to be behave exactly similar way. Okay, into this. So in that case, the best idea is to instead of testing with all, to test it with only one value, because their behavior is going to remain exactly same whatever values you are going to take it from them. Okay, so uh, so that is the thing that you have to uh, take care. So that means you want to find out taking a large test cases, then you have to check which are of the same nature, which will going to behave exactly same way. You group them, call it as an equivalence class, and instead of testing with all the values from that class, you test any take out any value test case, and then you can test it. It means whatever value from that equivalence class you have considered will take, it will going to behave exactly the same. So you have to take a representative value from the equivalence class. I'll come into some example. So how to determine that whether it's an equivalent class or not? So first we have to examine the input data that you are taking, and then you have to follow some kind of guidelines for equivalence class. I mean, determine that equivalence class. Say for example, if your I mean some range you are checking, if the input data to the program is basically a range of values, say number between 1 to 5,000. Okay, 1 to 5,000. So if the input data is what is called the range 1 to 5,000, beyond that these are we consider as an invalid. Now how to test that? What is the equivalence value? So any value within 1 to 5,000 are in fall in the same class. Any value less than 1 will going to be considered as another class, equivalence class. Any value which is greater than 5,000 are considered as another equivalence class. Okay, or so that means another way what you can do, one class which is valid class, sorry, one value which is within the valid range, another value which is not in the valid range. So what you can do, you take any value, any input value or any integer within the range 1 to 5,000 will consider it as a valid, and any value which is less than 1 or greater than 5,000 will consider it as an invalid. So they are one class and valid region another class. So take any value from the valid region and take any value within invalid region. You test your program. If it can detect, your program is absolutely fine. So, so there are three sets of values which are there A, B, C. Okay, so one equivalence class for every valid input values. So another equivalence class for invalid input values we determine. So this is I mean the way I have explained. So you can take any number for that. Say for example your square root. Okay, square root input value. What will happen? It will going to take an input value within the range 1 to 5,000, and it will going to calculate a square root. So first thing is that whether the value of I given is within the range or not. Okay, within the range or not. If it is within the range, it's fine. Then it will calculate. Otherwise not. So how to check it? You take any value from the equivalence class 1 to 5,000, any value, and you take any value less than 1 or greater than 5,000. Your program will can be executed. So that I have already discussed. So that can be a test suite. You can test with like -5, 500, 6,000. So -5 is less than 1, that is invalid. 500 is within 1 to 5,000, so it's a valid. 6,000 is greater than 5,000, that is also invalid. So that means all the things test suite you can take it from. Boundary value analysis. What is that boundary value analysis? A boundary value analysis means in this kind of program, ranging and all, or for loop and all, sometimes the most problem happens during the boundary areas. Okay, say I can give you an example. Say for you are accessing an array. Okay, so you know array starts from 0. So what we do, we always write I is equal to 0, I less than n, I plus plus. So sometimes what you may do it, you may write I equal to 0, I less than equal to n, I plus plus. In that case, you are not doing any error, but you will going to miss the value, because if you are starting from 0 an array index, it will never, you will never going to get a positions called n. Okay, if your size is exactly n. So boundary values are basically related to the equivalence class. I mean that you can calculate. I'll come back to our range problem again. So some error, programming error actually happens mainly at the boundaries of the equivalence classes. Say 1 or 5,000 that we have seen, and sometimes we skip or we may miss that particular critical case. That is, as I mentioned, less than or less than equal to. These are basically the boundary value analysis. Okay, so we have to select those test cases so that the boundary value can be checked carefully. In this example, we must check one. We have to keep a test case for 0. We're going to keep a test case for 1. We're going to keep a test case for 1,000, and we're going to test case for 1,001. So that means value which is just less than 1, value which is exactly the boundary, that is 1, value which is exactly the upper boundary, that is 5,000, a value just more than 5,000. If you are taking 6,000, the greater than equal to or less than greater than, you cannot able to detect with that. Okay, say if your value is less than, if it is greater than. Okay, so in that case, that I mean, if you do not use 1 or 5,000, you'll never going to see whether there is an by mistake equal to is there or not. Okay, if you are not interested in equal to, then if you take that 5,001, then in that case only it is going to be detected. But in the previous case, what happens, we have seen in this case These things is not detectable. That's greater than or greater than equal to, less than or less than equal to. In this case, it's whether it's equal to is there or not. In all cases, it will going to say correct. But if you don't want that equal to should be there, in that case, this boundary value you have to take it for your checking. Now, next is the other testing. I am skipping these things, mutations and all. So a few more testings are there. So I'm just skipping that thing. So let's see if I can discuss it later on. So now this is what about black box testings and white box testing. Now let's after that, that is after unit testing. This is a part of unit testing. Now let's come to integration testing. What is integration testing? Integration testing means you are developing every module, small module. You are passing through the unit test. Now what will happen? You have to. This is the time to combine all the modules. Okay, you time to combine all the modules. So once you are combining all the modules, then again also you have to test after combining. So that's what we called it as a integration testing. Okay. So you have to have a kind of a integration plan. We have discussed earlier also, if you can remember, that how to integrate and how to do the testing for that. So like different components of the software, you will go on joining together, integrating together, and then go on testing these things. So that needs a proper plan that which module to be added after which module. The next type of testing is the most bigger testing. That is kind of, you can say, validation. It's a system testing. That means once your whole software has been developed, you fully developed system, you will going to check whether it's performing as per the SRS document or as per the requirement specification or not, as per the requirement specification. So if it is performing, then what we call it is a system testing. So what are the testing, these things, integration testing that can be done? One is called big bang approach, one is called top-down approach, bottom-up approach, and mix approach. So these approaches are basically the planning, how we're going to integrate all the modules and then go on testing these things. What is that big bang integration testing? This is the most simplistic integration testing. All the modules, forget about any planning. Okay, all the modules, like there are 10 modules, you put all together. No planning, no ordering of integrating or merging those modules. You keep put all the modules together and go for a testing. Okay, so it's so this is applicable only for very small kind of systems. But if it's a large, it is not going to be a very good idea of putting all together all the modules, integrate all the modules or modules, and then go for a single time testing. So main problem with this approach is if there is any error found, it's very difficult to detect where exactly, because handling a bigger system is always difficult. Okay, so that's why it is applicable for the small systems. Okay, um, and if you get a error also, it is finding or detecting the location of the error or moving to that point of error or debugging itself is very expensive and time taking, and there may be some ripple effect may also have. What is bottom up approach? Bottom up approach is another systematic approach. Okay, it's basically a systematic approach. What is the bottom up approach is? Say I where from that idea has come. So I can show you tree. Say I have a tree. So I have a tree. Hierarchical tree I have. Say a fully binary tree. So what bottom up says? This is bottom. The leaf nodes are bottom. What it says, these are all individual modules. These are all individual modules. What you do, you merge two modules to form this module. You merge another two modules, form this module. You merge these two modules, form another module. You merge these two modules, form this module. Again, what will happen? These merged modules, you are merging two modules. You are merging these two modules. Okay. Again, these are the merged two modules. You are merging these two modules and you're getting the your ultimate software. So this is what we call the bottom-up approach. Okay. What is top-down approach? The reverse one. Starting from big one, you are just going on breaking. See, let's see what it is mentioned over there. So bottom-up integrations, it's integrate and test bottom-level modules first, okay, and go on updating. So what is the disadvantage of the bottom-up testing? Uh, it's basically made up of very large number of those sub parts or sub modules are there. Okay, in that case, what will happen? You will going to maximum case you will going to joining all the things together, and then you may go for a bottom up. So in this case, let me show you this example. If your branch is very many subsystems are available. So these things. Say there is a branch for a particular systems, you have many subsystems. Ultimately, what will happen? Many submodules you are basically putting together like a big bang, and then you are combining all together, integrating all together, and then you are going for the testing. So this is nothing but a big bang only. And big bang, you know that the problem which is there. So the bottom-up approach having this particular issue. What is the top down? Top down is the just the reverse. Okay, you start with a main function, okay, and then you are adding two subordinate modules. Okay, so say for example, your main function is this, and then you call two sub functions from there, say 2 or 3. You are integrating, and then you are adding some more sub function from there. So that means you are starting from the top, you are going on adding sub modules or subroutines in the top left from the top to the bottom, and you will going to cover all the functions call or for modules in that fashion. That is called top down integration. And mixed means it's basically mixing up of top down and bottom up. Some cases you may do top down, and some cases you may do bottom up approach. Okay, so that is the most common approach that industry follows. That is called mixed integration testing. Now, how to perform system testing? There are three types of testings which are there for the system testing. One is called alpha testing, one is beta testing, another is called acceptance testing. Possibly you may heard about something called alpha version, beta versions. Sometimes you some softwares are available freely at the very early stage. Okay, they normally give it free versions to use by the normal customers, and later on they put some cost into that. After certain years, they say that it's no more free of cost. So the software they first release by the company to be used by the customer, potential customer. Okay, that means customer actually also act like a tester. Okay, so that basically version is basically called the sorry. I did a mistake. Alpha versions, alpha testing is basically done by the development team only, and beta is normally the beta version of the software message that will going to be tested or experienced by the uh, customer. And let's see in details. I don't know whether it is there or not. Yes, alpha. No, I think I have missed to put that alpha testing. Oh, yes, alpha testing. Sorry, this is the alpha testing. So that testing is carried out by the testing team, but sitting in the within the developing organizations. So that is called alpha testing. So whatever testing, system testing they do, okay, after integration and everything, that is called the alpha testing. They are doing the testing in the sitting in the company itself, okay, developing organizations. And what is beta? Beta testing is performing by the customers in the customer side. Okay, the testing. So that means beta version of the software. Okay, and nowadays company what they do, that is the smartest that they show at the very beginning when they develop a software. It's to bring a software stable. Okay, they normally don't give it to the customer with the. I mean, they normally don't sell a software with by taking charges or money. What they do, they develop that system, do alpha testing, and then freely they distribute among the customers. Now customers are the very good testers. Okay, they will go on using those things and then just go on reporting these things to the company automatically, and then they go on debugging these things. So but since this is going on free of cost, customers also remain happy, or the users all remain happy. They use it, and they automatically during their use they may report errors. Okay, and accordingly they are the companies are building up their confidence by making it more error free. Now once they feel that the software is somewhere perfectly okay, and most of the errors has been detected, then they start selling with a high price. And that is the policy that company normally do, especially for the customized software, you can say, or what is that called, that service, software, proprietary software, if someone is developing, say Microsoft Office and all. Initially, when they develop that thing, initially they start distributing this thing free of cost. Why? Because people will going to use it, and the error report will automatically received by the company, and they have corrected these things. Now they, since they have observed that their software is performing very nicely, then they started the business. They start selling that software to the customer with very high price. So that's why the beta versions is normally done by the testing is done by the customer. And acceptance testing is what? That the system is testing performed by the customer, and then see that yes, it is ready to deliver or not. Once they said okay, now the system is ready to deliver, the customer will going to certify that it's fine, it's working absolutely fine, then you will say that software is being delivered. And there are two types of requirements. If you can remember, that is called functional requirement and non-functional requirement. In the requirement analysis chapter, uh, we have discussed these things. Okay, what is called the performance testing, that it actually check whether it satisfy the non-functional requirements or not. Say running in different operating system, say running in different network environment, say your GUI is user friendly or not. So all these non-functional requirements which you cannot exactly specify or nothing to do with the implementation directly. Okay, uh, functions or modules. These things can be checked during this performance testing. See, if you are running if you have developed a software and if it is running absolutely fine for Linux, and when you are trying to run it in Windows environment, it's not performing. So this performance testing is also very important, and that is basically part of non-functional record, because it's nothing to do with the functions. It's as a whole the performance of the system that you are measuring. Then it comes to the debugging. Now once your error is identified, the main task is to find out the exact reason of that error and then fix them. Okay, uh, and the debugging also having different approaches, and it's having all advantages and disadvantages. Okay, like one of the process is brute force method. Okay, what happens, you are just checking arbitrarily any of the line to find out where exactly the error is, what is the cause of the error, and then try to fix it up over there. Okay, so this is basically very least, it's considered as a very least efficient method. Okay, what we do normally, the way that you do it, if you are not able to find out where is the error is, you are putting a printf statement. Okay, after every line you are printing printf statement to see where actually it is stuck in. Okay, where my program is not working. Okay, so that is one of the approach for that you can adopt for brute force method. And normally as a programmer, C programmer, whatever you have done, sometimes you may have taken that idea of putting a printf statement to see where the error is actually. Okay. So that means printing the intermediate values, key what the value is coming after that and all. Okay, sometimes in some programming language or some integrated development environment is showing the intermediate values are also integrated, it's already there. Okay, but in C programming and all, it's not there, you have to write that of your own. Backtracking means, what is the backtracking? Going back. You start tracing source code is straight back from the statement where the error is occur, and you will go back. Okay, go back until unless you find out what is the exact cause of these things. So from the beginning of the statement where the error symptom has been observed, you will have to go back, come back. You have to move forward, and then you have to go back. So that means this in this program. Okay, in this program you will start it from main, you will check it all the lines, then once you are detecting you will again go back. Okay, so that what is the basically the reason for that particular program. So this problem is that as and when you are moving from first line to the last line, and once you are getting these things, weight tracing back is basically increases. Okay, so I mean which paths you have to correct and everything, that itself I mean it's very difficult to detect from there. Okay, so for a complex program these ideas are not very effective. So what are the debugging, how will carry the debugging? Basically you have to have an idea of the program design. Without the idea or logic of the program you cannot do it debugging. So you sometimes the debugging may require some full design of a system. Complete restructuring may be necessary sometimes. Worst cases, debugging of the system. Okay, uh, and sometimes some small mistakes, common mistakes are done by freshers. Okay, like students like you normally you do, like uh, for wrong use of ampersand address, less than, greater than symbols. Okay, uh, so that we can as an experienced programmer one can easily detect that thinking. Say someone is saying message is coming in the Linux code dump. So we know code dump means somewhere you have used wrongly the use of a pointer or address. So whenever you are going for a correcting an error, there is a chance that you may introduce more error. You can put more error over there. Okay. So after every round of such error fixing, you have to do a kind of a testing. What we call it as a regression testing. That means correcting and again rechecking, correcting and again rechecking. So I have not gone through in details the regression testing and some other testing. So I mean, let's see if I can discuss sometime in some other class. So, so if you have any queries, just please let me know.